Hello everyone. In this video, we're going to start to talk about lesson 5, which has to do with sampling. Okay, and so what we've done so far in this course is all kinds of stuff with one variables and two variable uh, plots, summaries, all kinds of stuff. We've worked with a lot of data, but I've always given you the data. So it came from somewhere, but I gave it to you in a nice format, and we didn't really worry about where it came from. Lesson 5 is going to be a short lesson, and it's going to talk about where uh, the data actually came from, or how can you actually collect data. Okay? Before I said that statistics or the data comes from either an experiment or a survey of some kind, and so we're going to talk here about experiments and surveys. So, as I always begin every lesson, there are going to be some terms involved here, and the first term is an experimental study. Okay, an experimental study is when a researcher conducts an experiment by assigning a subject to certain experimental conditions and then observing outcomes on the response variable. Okay, so what does that mean? So, for instance, if I were interested in testing a vaccine like they are now for COVID 19, okay, they are doing clinical trials, which is a word thrown out a lot, which is an experimental study of sorts, okay, where uh, you have a number of different conditions that you can apply to the person, and so you put them into different groups and you see what happens. Okay, and so when you have an experimental study, you have uh, a couple other terms that go along with it. One is treatment. Okay, uh, and the treatment is the experimental conditions which correspond to assigned values of the explanatory variable, and then so that's a treatment. And then also, on the other hand, when you don't have an experiment, you just have an observational study. Okay, and an observational study is when the researcher observes values of the response variable and the explanatory variable for sampled subjects done without anything being done to the subjects. Okay, so in an experiment, I split my subjects, whoever I'm taking data on, into groups. I do something to them. I give them a drug. I do something else to them. Okay, and then I observe what happens. In an observational study, I just go out into the world and I observe what's happening. I don't do anything to the subjects. I might not put them into groups. I could still put them in the groups, but I don't apply some treatment or non-treatment to them and to see what happens. Okay, so uh, experimental studies, the first thing that we've talked about, can lead to much stronger conclusions than observational studies, and the reason for that is uh, because you can control for what I talked about in the last lecture as lurking variables and other things. So uh, I can think a lot about how I want to put these people in groups and do something to them. So, for instance, if I were interested in looking at blood pressure, a blood pressure medicine, if I was interested in testing whether it was effective or not, okay, I can look at my subjects and I can look at all kinds of characteristics, and I can uh, put into group put people into groups by age, by whether or not they have high blood pressure, by all kinds of stuff, and I can control for extraneous things that might affect the outcome. But in an observational study, I just probably go up to people and ask them a question. They answer the question and I get the data. I don't really have as much control over what's happening in an observational study. And so I can say less about results from an observational study than I can from an experiment. Okay? I couldn't say if a drug was good or not, probably from an observational study, but I can from an experimental study. Okay, so that's great. And if you are in a biology or chemistry or physics, if you're in a physical science, you probably agree with that, because that's what you do in and out all day is experiments, um, depending on your major. Okay, and so why not always do an experimental study? Okay, all right. So they're preferable, but they aren't always possible. Okay, so they are the better type of study, but it may not be possible to run an experiment. Okay, so when does this happen? When aren't they possible? Well, there may be ethical reasons involved. Okay, so as an example, maybe you shouldn't expose the subjects that you're interested to certain treatments. For instance, if I were testing if a drug were effective on treating cancer, you'll often hear of a treatment and then a placebo. Okay, a treatment is when I apply this drug that I think I'm interested in, and then a placebo is where I give the subject nothing. Okay, or I give them a pill that doesn't do anything, or a treatment that doesn't do anything, and then you can see how the two react. But if I'm treating someone for cancer, it's not ethical at all for me to give someone who has cancer no treatment at all. And so maybe I need to give them another type of treatment, or it may be in a circumstance where I just shouldn't do an experiment at all. Okay, because it's not ethical. Maybe I just need to observe what happens. Certainly, that's not the case for treating drugs. There are other things that we can do, but I just use that as an example. Okay. Another thing is it might be hard to control if people follow directions. Okay. Certainly, everyone knows that people do not follow directions very well. Okay. After last semester, I'm very aware that students are not always great at following directions. Okay, and everyone is not great at following directions all the time. So it's hard to know, or it's hard to control whether people are taking the drug that you want them to take on time. Are they always taking it? There could be many things that are hard to control there, right? And in certain circumstances, it may just not be possible. And for experiments, it's a lot harder for people to get, for the researchers to get people to participate. Okay. And so there may be some risk involved in the survey, or people may not want to take the time to be part of it. They may drop out after they add, halfway through the treatment, so on and so forth. Okay, and so when you have those cases, we may just have to go to an observational study. So you may have to take a survey. Maybe there's some data already out there that you can collect and change, not change, but there's things that you can put together to suit your purposes, so on and so forth. Okay, and so let's talk about that. So we're going to talk about observational studies now and the things that go on in an observational study. And so in both an experiment and an observational study, you have to do a sampling. So you have to go out and you have to pick people, places, or things that you want to collect data from. And so whatever question that you have in mind, you usually have a population and a sample like we talked about in the first lesson, right? And that leads to what's called a sampling frame. Okay, a sampling frame are the list of subjects in the population from which the sample is taken. Great. Hopefully, the sampling frame encompasses all of the population. So if I was interested in finding out something about the population of Shippensburg University students, hopefully I could get a list of all Shippensburg University students, and then that would be my sampling frame. Okay, it's the thing where I take the sample from. That may not always be the case, though. I may not be able to get all people. So certainly the census is coming up, okay, or the census is being taken right now. And the census, its aim is to have all people respond to it. Okay, and there's a number of important reasons why you should respond to the census. It has a number of big implications if you don't respond. Okay, so your state could get, so if you're in Pennsylvania, which most of us probably are, if you don't respond and if you aren't counted, there are implications such as Pennsylvania will get less money, so on and so forth. The number of electoral votes that are in the presidential election change based on the census. Okay, so it counts the number of people and then gives each state a number of electoral votes based on the population size of that state. So if you don't do the census, then you aren't being counted, less votes, so on and so forth. So there are a number of implications there. Sorry about the rant. So there's a sampling frame, and there are good ways to sample, and then there are bad ways to sample. We'll talk about each. Okay, so some good ways to sample, which we'll focus on. One is called a simple random sample, or when you do simple random sampling. Okay, another one is called cluster random sampling, and then the third one that we'll talk about is called stratified random sampling. And then, of course, there are some bad ways to sample. One is convenience sampling, and then the other one is called volunteer sampling. Certainly, this isn't an exhaustive list of all the ways that you can sample, but it is good enough for us. All right, and so we'll talk about first the good ways, then the bad ways. A simple random sample is when you select however many subjects that you want from the population at random, such that each person in the population has an equal chance of being picked. Okay? So that means that everyone, so if I was sampling from the United States, I would assign to each person the same probability of being picked. Okay? It's going to be very small, 1 in 300 and some million, I think, right now. Okay? But each person would be equally likely to be picked. A simple random sample is optimal because it minimizes all potential biases and human error. Okay, so we'll talk about bias in just a second, okay, later on in the next video. But when I sample randomly, human error goes away. So it turns out that humans are really bad at randomness, okay? And there's a number of ways that I could show you that you're bad at being random. Okay, humans are really bad, and so when I don't pick truly randomly, then bad things can happen. Okay, so that's why a simple random sample is good. So here's an example. Suppose I'm interested in finding some information about students at Shippensburg. To select the 100 students, I use a random number generator to select names from the registrar's list of students. Okay, so the registrar has a list of all possible students, okay? And who knows how many there are. Say there's 4,500 undergrad students at Shippensburg. I would use a random number generator, okay? And you can look up random number generators online, and I could say I want 100 numbers between 1 and 4,500, and then it would pick 100 random numbers, and those are the people that I would choose. So that's simple random sampling. Now, the second one is called cluster random sampling. Okay? In some cases, defining a sampling frame may not be feasible, but it may be possible to identify clusters of different subjects. So sometimes sampling is going to be hard. Okay? Shippensburg would be easy, but if I were to try to sample the whole United States, that of course would be really hard. Okay, because there are a lot of people and none of them, or very little of them, probably want to talk to me. And so I wouldn't be able to collect all possible people to make a sampling frame and to do simple random sampling. So it may be possible for me to identify clusters of subjects. So maybe I can't identify single people in the United States, but I can identify zip codes or counties or maybe states. okay? And those are clusters of subjects. So what cluster random sampling does is it divides the population into a number of different clusters, such as maybe if I'm trying to find information about a city, I could divide it up into blocks, okay? Then after making those clusters, I can select a simple random sample of those blocks and survey all possible subjects in the block, okay? So, for instance, if I had 10 city blocks that I were looking at, I could randomly sample from 1 to 10, 2 of them, and then try to survey all people on those 2 random city blocks. Okay? That's my dog in the back barking. If you could hear that, I apologize. So what are the advantages of cluster random sampling? Well, the advantage is you don't need a reliable sampling frame. You don't need all people in the city. Okay? You don't need to know who they are. You just need to know the blocks. And it's a good alternative when simple random sampling is excessive. And what I mean by that is I'm not going to look in a phone book and try to pick out all possible people. That would be excessive. I can do something like cluster random sampling, which still is random of sorts and gets the job done. Of course, there are some disadvantages too. Okay? The disadvantages of cluster random sampling are it usually requires a larger sample size for the same precision. Okay? And what that means is it's not as good, so I probably need to take more samples than I would with simple random sampling. Okay, but we really don't need to get into that too much here. And selecting a small number of blocks may result in more homogeneous samples than in the population. So this is an important point, okay? And what it says is if I only have a few number of blocks and I sample those, it may not be representative of the whole population. Okay, so for instance, if I were really interested in housing prices in a city, and I split the city up into different streets, and then the 2 blocks that I happened to randomly pick were both really affluent, wealthy blocks, I sample them, housing prices are going to seem really high, okay, because of those samples, because of those blocks that I picked. They weren't representative of the whole population, and so that leads to incorrect conclusions. Okay, homogeneous means the same, okay, or similar, and so if I pick similar blocks, I'm not getting the whole story. And the last one that I want to talk about is stratified random sampling. All right, so this is in a similar case where simple random sampling is not available to me, and so I have to do some other thing. And so in some cases, it may be beneficial to view the data in different groups or strata. Okay, and so stratified random sampling is when I divide the population into separate groups called strata, based on some attribute or characteristic. And so that could be maybe I split people up by year in college. First year, second year, third year, fourth year, plus. Okay? And then I select a simple random sample from each group. Okay? The advantage is that you can include in your sample enough subjects from each group that you want to evaluate. And so in cluster random sampling, that disadvantage that we talked about was that I may not get a representative sample. In stratified random sampling, you're sort of guaranteed that because I can split the data up into the groups that I'm interested in hearing from. Okay, so it doesn't happen that all of the people or all of the groups I select were all freshmen or first year people. I make sure to sample some from each. The disadvantage here is that you must have a sampling frame and know the stratum into which each subject belongs. Okay, so I have to know who the people are, and in addition to knowing who the people are, I have to know what their group membership is. So I have to know that they're a first year, or that they're a third year, or that they're have been here for 6 years. Okay, and so that is more challenging, especially if you want to sample a bunch of people. Okay, so here's a visualization of how each of them work, and so hopefully it might help you understand if you were a little confused by the definitions. So I have 3 rows of plots. Each of them talk about something different. So in each plot, okay, in each row of sort, each plot, there are a bunch of points. Okay, and they might actually be stars. Okay, each star represents here students. Okay, this is about students in high school. So I have a number of students in high school. Random sampling occurs when I look at each of them individually. I don't put them in groups. Okay, I look at each of them individually, and then I randomly select 12 of them. Okay, and so you'll see that there are 12 X's in the top one, and they come from the whole population, where each person was equally likely to be picked. Okay, so they're all over the place. That's random sampling. Stratified random sampling, you'll see that I broke them up into strata or groups, and the groups I picked were their year: freshman, sophomore, junior, or senior. Okay, and then I selected at random 3 people from each strata or group. Okay, so you see I selected 3 freshmen, 3 sophomores, 3 juniors, and 3 seniors. All right, the last one, cluster sampling, you'll see that I grouped the points into different clusters. Okay, maybe it's the tables that they're sitting at lunch or something. Okay, so the tables they're sitting at lunch, each cluster has 4 people in it. Okay, and so you'll see that I randomly selected the clusters, not the people, but the clusters, and then I talked to or sampled the 4 people in each of the 3 clusters I randomly chose. Okay, so here's a your turn. I give you a little setup, and then I ask you, I describe 3 different sampling procedures, and I want you to identify whether it's simple random sampling, stratified, or clustered. Okay, and so that's where I'll stop this video. I'll see you next time.